This is the final module of the Inclusive Mathematics PD series. Module 6, Mathematical Problem Solving, allows you to put together everything you have learned in this series to differentiate rich mathematical tasks to make your math instruction more inclusive to all learners. By the end of this module, you should be able to compare and contrast the structure of explicit instruction and problem-based learning lessons. You will be able to describe ways you can scaffold and/or differentiate problem or task-based learning activities. You will also be given time to explore and adapt given problem-based learning activities to make them more inclusive. This is another module that is great to work on with your colleagues for some collaborative brainstorming. In one of our earlier modules, I described pedagogy as falling on a spectrum. This is certainly not a comprehensive list of all pedagogical approaches, but most pedagogies will fit somewhere on this spectrum. Methods that are more toward the left are more teacher-driven approaches, where the teacher expertly facilitates the lesson with a goal of mastery learning of specific and narrow learning objectives. Generally, the most extreme teacher-driven lessons are direct instruction and systematic instruction. These are highly scripted lessons that utilize frequent prompting from the teacher. This pedagogical approach is generally used in special education for students with the most intensive support needs to teach discrete skill acquisition. Methods that are more toward the right are more student-driven approaches, where students pose questions or problems and develop their own procedures for following them. Similarly to direct and systematic instruction on the left, authentic learning, which is all the way on the right, is also typically used with smaller populations of students during enrichment activities or supported projects, like science fairs, where students are designing and defining their own questions and procedures. In reality, a majority of our K-12 math instruction falls somewhere in the middle on this spectrum. Good math teachers are flexible enough to provide variety in the way they approach instruction, expertly sliding back and forth based on the lesson goals and their students' needs. The pedagogy spectrum I have been showing you is part of a larger document I created with additional context and resources for understanding this range of teaching methods. You can read this document more clearly if you download the document for your reference. The QR code in the upper right corner of the screen will take you to that PDF. On the pedagogy spectrum document, you'll see I align the pedagogy with some of the underlying learning theories that influence those methods. I also align the methods with Stein's levels of discourse that you might expect from students while using those methods. I also align them with Benchy and Bell's levels of inquiry. These are the levels of inquiry you might expect when you use certain methods. For a more detailed explanation of this document, you can review my video overview, which I've linked through the QR code in the bottom left corner. For the purposes of this module, I'm going to focus on a typical structure for lessons that fall in the middle range of this spectrum. Toward the middle left is explicit instruction. The general structure of this lesson would start with an opening that clearly articulates the goals for the lesson, which are usually narrow skills so we can work toward mastery learning. Also in that opening, you should build relevance for students and provide some essential review of prerequisite skills that will be needed for the critical content. The body of the lesson is usually an I do, we do, you do format where you model the skill, do some guided practice, and then when they are ready, do some independent practice. You start with high support of modeling and then slowly back off the support toward independence. When you use this method, students are usually grouped with similar ability levels because you are targeting narrow skills. You close lessons with an assessment and explicit wrap-up that draws students' attention back to that learning goal and then what they can expect to learn about next so they can see the broader picture. The problem-based learning structure falls more towards the middle right of our spectrum, and this could start with a similar opening that sets goals, only this time the learning targets would be a little bit more broad. You should also review and build relevance here for this type of lesson. The body of a problem-based learning lesson is what looks a little bit different. Rather than beginning with the highest level of support like you do in explicit instruction, you actually start with the lowest level of support and then add in scaffolds as needed based on your formative assessment of student needs. You present a collaborative, complex task and have students work together to solve it. You want to group students with mixed abilities for this method so that they can learn from one another. But be careful, you don't want to put ability extremes in one group, or you may not be giving each individual the right amount of challenge. You might differentiate the task from the start based on your groups. But you want to be careful that you aren't lowering expectations for some students by assuming that they can't do the original task. It's really a careful balance. In between these two pedagogies on the spectrum are instructional activities that involve guided and supported practice. They may be structured like the we do part of explicit instruction, where students independently practice but with support. They might be station activities or centers or games, or they could be cooperative or other collaborative activities. I'd like to illustrate the nuanced differences between lesson structures along the spectrum by using one example topic and then describing different lessons on this topic that fall at various places on the spectrum. We will use the topic of using coins to pay for things. That's a pretty broad topic. I may want to use systematic or explicit instruction when I have a very narrow learning target or when focusing on declarative knowledge skills like coin identification, the values of coins, or skip counting. I could also use explicit instruction to teach procedures for how to pay for something using coins, as I model that process with my metacognitive think aloud. I could do some guided and supported activities through centers or games if students maybe had to show multiple ways to make certain coins amounts. They could do matching and sorting games like dominoes, bingo, or picture sorts, where they can show different representations of the same amount. A lesson could be more problem-based if I create a task that has more than one right approach and more than one right answer. Maybe I create a scenario for students to go shopping within a budget. Finally, if I wanted to push all the way to the right on the spectrum, I could have students come up with their own project that will involve using coins to pay for things. Like maybe they set up and run a class store. These authentic learning opportunities are not usually just single lessons. They are usually more long-term or at least take place over an entire unit. Hopefully this example helps you understand how the methods you choose may differ depending on the goal and purpose of the lesson. We also need to think about the needs of our learners. If you choose problem-based or inquiry lessons, you may want to make sure you're prepared to differentiate the tasks as needed to support all of your learners. I am going to show you one problem-based lesson and describe with a think aloud how I differentiated it for my students. Then I will show you two other lessons and walk you through the lesson differentiation process for each. This next part is really great to do in a small group so you can brainstorm ideas together. My math example comes from the Math Assessment Project website. It is a lesson called Creating a Measure for Slope. You can use the QR code here to find all of the lesson materials. According to the resource website, this lesson is intended to assess students' understanding of the 4 quadrants of the coordinate plane, while at the same time introducing them to a mathematical understanding of slope. This task helps students to link their intuitive understandings of steepness to a more precise calculated measure of slope. This is a wider goal because deepening understanding might look different for different students. This makes it a great lesson for problem-based learning. I'm going to think out loud how I scaffolded this PBL lesson to make it more inclusive for all of my learners. This grade 6 lesson begins with a pre-assessment to see what students know already about the concept of slope, which they are calling steepness in this lesson. We are also checking to see if students can plot coordinate points and create line segments from those coordinates and then put them in order from least to most steep. This pre-assessment may help me put my students in appropriate groups for the actual lesson, and it may help me determine what supports I need. So I would probably do this on a day or so prior to the actual lesson. On the day of the lesson, I want to begin by building relevance and activating their prior knowledge. This anticipatory set activity is not actually in the lesson plan. It is something I added myself as an additional support. I would first show students a series of pictures and then ask them some questions. Looking at roller coasters A and B, which one would cause a bigger drop in your stomach going down? Why do you think so? Which ski slope would send you down the hill faster? Why do you think so? Which set of staircases would take more energy to climb? Why do you think so? In today's lesson, we're going to use all of the ideas you mentioned to discuss the concept called steepness and what that really means. Also, not included in the lesson materials is explicit review of coordinate points. But I know that's going to be important in this lesson, so I added these to my anticipatory set as a scaffold, because looking at the pre-assessment and lesson materials, I see these students will need to plot points. During this activity, I added some color coding of my X and Y axes as a visual scaffold. I would walk students through plotting a few examples, and then give them some immediate feedback. I would be sure to plot some in the different quadrants, and continue to provide that immediate feedback with this review. Here's one more example of another quadrant. And of course, I'm including feedback as well. So now in my opening, I have built relevance, activated prior knowledge, and reviewed essential prerequisite skills needed for this lesson. Most of this opening came from my own head, my own expert review of the lesson, not from the lesson plan itself. That's important for you to remember. For the body of the lesson, I present the collaborative task from the lesson materials. Students are given 8 cards and work in groups to sort the cards from least to most steep. 4 cards are visual line segments already plotted, and 4 cards give the coordinate points. As students work, I walk around the room and ask probing and guiding questions to make sure students are not straying too far from the learning goal, or that they are not emphasizing misconceptions. During this time, I am looking to see which groups may need additional scaffolds. I may have graph paper ready for students who need to visualize those coordinates. If I have a group that cannot yet independently plot those points, I can give them all pre-plotted cards instead of giving them a mix of line segments and coordinates. Again, these are all adjustments I am making as a teacher. Oftentimes, our lesson plan materials do not include all of these adjustments. The next step of PBL is promoting discourse. Students from different groups present their findings, and I give different levels of support depending on the group's needs. I can ask more leading questions for groups that need more support, and I can ask more open-ended extension challenge questions for those who need that challenge. Maybe I even have some more difficult coordinate points for some groups to plot if they finish the activity quickly. Depending on what the different groups discuss, I want to be ready with some discussion points of my own. Those wide learning goals can be unpredictable, so I need to be prepared to draw attention to important parts if the students don't get there on their own. Here are some other questions I could ask. This question here is a little more narrow if they need it. These questions actually did come from this particular lesson planning materials. In fact, the Math Assessment Project, which is the site where I got this lesson, does a great job giving you potential errors and prompts for your students who have a range of learning needs. There is actually more to this lesson, but I'm going to stop here because I think I illustrated my point. We can use flexible methods when using problem-based learning methods, and we can be ready with some of those 8 guidelines from Dobler and colleagues or some of the high-leverage practices I reviewed in an earlier module. Combining these with PBL can make math instruction much more inclusive. Now it's your turn to do some brainstorming. I have 2 more lessons for which I will walk you through some probing questions as you plan how to differentiate and scaffold the task. The first lesson is for middle school. It's another lesson from that Math Assessment Project, which is one of my favorite resources, by the way. This task is called Designing a 3D Product in 2D. Essentially, you give student groups a task that says you have been given 3 yards of heavy fabric from which to design a sports bag that can hold as much as possible. Right away, I hope you're thinking to yourself about what those critical learning goals are, both short and long term. Take a moment to pause the video and brainstorm some of these skills with your colleagues. What did you come up with? Did you note any of these short and long-term skills I have listed here? Discuss in your groups which topics you would review in the opening and why. Also discuss how you could support and scaffold those other skills during the body of the lesson. For example, what materials would you give them? What other context is needed? Are there any seamstresses out there? Did anyone think about a seam allowance for sewing? While I wouldn't necessarily think all of my students would be ready for this, having some students include a seam allowance could be an interesting way to add a challenge for those who are ready for it. For some students, the nature of the task could be a little too open-ended, so you might want to consider giving some additional parameters for structure. You may even make a graphic organizer with some prompts to help organize their thinking as they work on the tasks. How could this be adapted further? Take a moment, pause, create a few more ideas. Those questions I walked you through can help you maintain flexibility in your approach, with some students getting more explicit supports than others as needed. Okay, here is another example. This example is an elementary lesson from Robert Kaplinski's website. It has some lesson materials, but not as many as the Math Assessment Project website, so it's important you think through the scaffolding and supports for yourself. This lesson, which is about what rides are you the right height to go on by yourself at an amusement park, there are some rides pictured on the website. On this slide, I'm only showing a few of them here. They give you a lot more than this. Each ride has a height requirement. If you notice, some have a minimum height and some give a maximum height. Some give both a minimum and a maximum, and some give this height requirement with an or situation. Like look at Lucy's tugboat. It says 42 inches or accompanied by a responsible person. Already, you should be thinking about questions you might ask students to create some discourse around this. Why might some rides have a minimum? Why a maximum? Why, for some, does it say it doesn't matter as long as you're with a responsible person? It would be really interesting to hear students' ideas. They probably would differ depending on what grade the students are in. Many PBL tasks can be used across grade levels. Talk in your group about how you might build relevance and grab students' attention at the start of this lesson. Pause the video and write down some ideas. In your group, discuss what skills are students developing with this lesson. What are the priority short and long-term instructional goals? How might you need to adapt this task? Now, work on a lesson body in closing with this task that incorporates some of these HLPs, which you should notice also overlap with those 8 guidelines. Notice how in this module, I scaffolded your thinking about these 3 lessons with a bit of an I do, we do, you do structure. First, I modeled an example of how I adapted a lesson with my Think Aloud. Then, I walked you through another example, giving you some additional feedback, some confirmation feedback with my ideas along the way. Then, in the third example, I just gave you some probing questions without my feedback and confirmation of your ideas. I wanted to do this to show you that you can use explicit instruction as a support and scaffold even for complex learning tasks, even at the adult learning level. As we wrap up this professional development series on inclusive mathematics, I want to circle back around to this mantra or mindset. All students can think mathematically. We can use flexible methods with thoughtful scaffolds and supports to make sure all students have appropriate challenge. Beyond the lessons you discussed during this module, I encourage you to get together with colleagues to explore more of the lesson resources I'm sharing with you through this QR code. These lessons are a great starting point for incorporating more rich mathematical problem solving into your lessons, as long as you consider diverse learning needs and supports while you're implementing them. I hope you enjoyed this Inclusive Mathematics Professional Development Series. My name is Dr. Tara Kazarowski. You can find more of my education videos on my main YouTube channel.